Alright, you guys, so for number 7, we have that Annie owns 4 cafes. That's the dream, isn't it? Owns 4 cafes represented by the points A, B, C, and D. So all these different points that we're seeing on screen are different cafes that Annie owns. Annie wants to divide the area into delivery regions. So that means that, for example, B is going to be delivering all up here. C is going to be delivering all that's over there. And then A and D, clearly, we still need to complete the Voronoi diagram because, as it says here, we have an incomplete Voronoi diagram, right? So somewhere along this line, we will be splitting up between A and D and seeing who delivers which area, okay? That is our job. That is probably going to be our task, and that's what's going to show up later, right? Now, you probably clicked on this video because you have no idea what a Voronoi diagram is. First of all, at some point in my life, I also did not know what the heck a Voronoi diagram was, okay? So this is something that anyone can learn. Don't be scared. I know there's a lot of buzzwords we need to go over, but let's go piece by piece. There's 3 things you will learn in this video, yes or yes. Okay, you will understand a little bit better what a Voronoi diagram is. You will understand a little bit better what we mean by perpendicular bisectors, which is probably the biggest buzzword you're ever going to have, okay? And midpoints, right? These are the main things we need to go over. These are the main things we need to understand. So, a Voronoi diagram, the reason people use them is that it helps you split up areas evenly. It helps you split up areas / distances evenly. I mean, more than areas, I think it helps you split up distances more evenly. That's a better sort of explanation, see? Because what would make sense for Annie, right, is to plop into this graph all the different sort of locations of the cafes, right? And so it would make sense that the distance from here to here is the same as the distance from here to here. Okay? The distance from here to here is the same as the distance from here to here. The distance from here to here is the same as the distance from here to here. And so that is the main sort of intuition of the Voronoi diagram. First, you put down your cafes. First, you put down A, B, C, and D. And then you figure out where are those distances so you can split them up evenly. Okay, it has to be even. So if you take a good look at, for example, between B and C, right, you can tell that it fills up at least one square. It fills up at least one square. And then it fills up a little bit of the next, right? And then it fills up a little bit of the next. And so if you look at that, this distance right there is the same as this distance right here. And that's the whole point of the Voronoi diagram. That is why you use it in the first place. It helps you figure out how these distances work, yeah? Now, of course, this has a bunch of sort of information and keywords aligned to it, okay? So the first thing I will tell you is that A, B, C, and D in the world of Voronoi diagrams is what we will call sites, okay? And the lines that I am now putting in red, okay, these are your perpendicular bisectors, okay? And that is a loaded word, perpendicular bisector. So there's 2 things happening here. On the one hand, coming back to the example between B and C, so you have a line that goes from B to C like this, right? So this line here, what that red line does, okay, the one that's remaining, the perpendicular bisector, well, following its name, it bisects it, okay? And bi, what comes to mind? Bisexual, so it's 2, okay? So bisexual for 2, bisect for 2. It's like you're cutting it in 2, right? So think about it that way. On the one hand, you're dividing it by 2. So this perpendicular bisector, what it's doing, the line that's in red, it's cutting the pink line in 2. So that means if this distance, I'm just going to make it up, yeah? But if this distance from here to here is 5, then the distance from here to here also has to be 5. Because you know that this red line that's drawn onto the Voronoi diagram is a perpendicular bisector. It's cutting the pink line in half. If this up here is 3, then the one on the bottom also has to be 3, okay? Now what it actually is, if I do it by just eyeballing it, it looks like it's well, I mean, this is 1. It might be like 1.5, okay? So that's what it does. It bisects it on the one hand. On the other hand, here it says that it's perpendicular, right? And perpendicular, you should be thinking in slope. There's two main types of slope that you will encounter, okay? You have perpendicular slopes, perpendicular, and you have parallel, okay? And the quick conclusion regarding both is that for perpendicular slopes, which is the harder one, you have that the slope of the first one times the slope of the second has to equal -1. This is also why you might have heard that for perpendicular slopes, it's the negative reciprocal of the other one. So when they say reciprocal, it's just a fancy way to say like 1 divided by that, right? And then negative, because of course there's a negative right here. See? So the hardcore mathy formula, it's either of these. You can remember it however you want. The other sort of cool piece of information is that because they're perpendicular, because they're sort of like perfect mirrors or something like that, you end up with a bunch of 90 degrees in here. Okay? That's not so relevant for us in this case. What really matters is this formula right here for perpendicular. All right? For parallel slopes, which is not the case, but I mention it because, well, if you read perpendicular, you should be thinking slope. If you're thinking slope, you should also know that parallel is a thing. So for parallel lines, you have that the slope of the first equals the slope of the second, quite literally. So parallel lines are lines that never touch. And why do they never touch? They never touch because they have the same slope. So they're always growing at the same sort of speed. And so if they grow at the same sort of speed, they're never going to touch. If one of them were to grow a little bit faster than the other, then eventually they would touch. But if they both grow at the same speed, then they are never going to touch. Okay? Think about two cars going at exactly the same speed. They're never going to pass each other. But if one of the cars is just going a little bit faster than the other one, then it will pass it. And it's not a parallel slope. It would be different slopes. See? So parallel slopes, they're equal to each other. This is the fancy formula you have to remember. Visually, I put it down there. For perpendicular slopes, usually you have something like this. They sort of cross each other. And the big detail, as I mentioned earlier, is that you have a bunch of 90 degrees within them. Okay? So that is the perpendicular bisector. In conclusion, if you draw lines between the sides, right, lines that I'm putting right now in pink, okay, the perpendicular bisectors are the one I'm putting in red. Okay? So the last buzzword I'm going to go over before even embarking upon the problem, but it's just such important buzzwords and vocabulary that you need to know. The last thing I'm going to talk about is that a midpoint, okay, following its name, is quite literally the middle of a point. Okay? So notice, why is this so relevant? The perpendicular bisector, as I said, the line in red, is cutting the line in pink in half. If it's cutting it in half, where does it cut it in half? Well, right at the middle. Ah, so here, where it's cutting it in half, you have the midpoint between B and C. You have to have the midpoint here because the perpendicular bisector is cutting right through there. Interesting. So now we have all the information we need. Now the monologue is over. Now let's go ahead and do the actual problem. The first piece of information that they give us is, look at that. The midpoint of CD is 5.5, 1.5. So the midpoint of BC, I'm following the colors, right? So I have this line in red, which would be the perpendicular bisector. And then I have this line connecting the two sides between C and D. Should look something like that, ¿cierto? This midpoint here, I'm just going to write it. So this is midpoint of CD, and midpoint CD, they just told us, is 5.5, 1.5. Okay? There we have all the information. I'm going to erase what I have up here because I used it just for explaining. Now we're talking about only what's relevant for the problem. And for the problem for part A, we have that we need to show that, which is already important that I acknowledge, show that The equation of the perpendicular bisector, we already know what that is, of CD, is this right here. Okay? So the perpendicular bisector of CD is the line in red that I have drawn right now. That is the equation that we need to find. All right? The other important thing that I have to mention is that here it says show that. Guys, whenever you have a show that exercise, it means that this is true. Why is this relevant? It's relevant because maybe for part B or for part C, it's very relevant that you have something from part A, right? And if this is show that, that means you can skip it and use this as true. Use this as factual information for you to be able to solve B or C. Now you might be telling me, why would you do that? This is worth 3 points. Why would I skip it? Well, you might have to do that if you're running low on time, if you tried to solve and you couldn't and you need to be time efficient. If it says show that, know that you have the option to skip it and use this information as factual as true. All right? The show that, I'm just showing you the mark scheme. The show that is reaching the same thing. It's no new information. Part A is giving information that might be important for B or C. Okay? So that's the first sort of test taking strategy. Whenever you have a show that exercise, you can use it as facts and maybe solve something down the line. Claw for points wherever you can. ¿Cierto? All right. So back to it. We need to show that the equation of this red line is this right here. Okay? Now, for arming the red line, on the one hand, we have the midpoint. See? Now, before delving into what we have, let's first understand what we need. So, right now for part A, technically, I am creating a line. Creating a line. Or an equation for a line, right? And through creating the equation, creating an equation of a line, we need to reach this guy here. So what are my tools, right? Well, the main tools that you have are in your formula booklet. So go to your formula booklet, get familiar with it. One thing is having it the day of the test, which you will, and another thing is knowing what's in it, okay? So once you establish that you need to create an equation of a line, you should be familiar enough with the formula booklet that you know that there's a part somewhere in here that you know that if you search you will find of how to create an equation of a straight line, okay? So guys, this is the level that I need you to reach. You need to be able to establish, what's the procedure here? I need to create the equation of a line. What are my tools for creating an equation of a line? I know that that's somewhere in my formula booklet. Let's look for it. You will find it and you will go from here, okay? That is the ideal procedure, you guys, okay? Establish the buzzwords, establish the procedure, and more likely than not, go straight to the formula booklet. Don't let your ego grow. Don't say like, I have the formula booklet, so I don't need to memorize it or whatever. No, you don't need to memorize it, but you do need to know what's in it, okay? It is an additional tool the day of the test. Use it. Here, for equations of a straight line, you have 3, okay? I'm not going to jump too much into it, but I will mention, and the biggest tip I can give here, is that usually you will start here. Usually you will start here, and from there you can easily reach this, and you can also easily reach that. For creating the equation of a straight line, you usually start with what I have in red, right? What I have in red, you might have heard it as point slope formula. Why is it the point slope formula? Because following its name, you need a point and you need the slope. And that's all you need. For creating the equation of a straight line, once you have a point and once you have a slope, you can go ahead and plug it in. For example, this x1 here is the point that you found, and this y1 here is the point that you found. This m here is the slope, right? And this y and this x, you're going to leave it as it is because that is part of your answer, the y and the x. See? So all you need to plug in is just a point, just a slope, and you're good to go, right? So I'm going to write down here what I will be using. So for part A, I know I need to use the point slope formula. That it? So here's the point slope formula straight from the formula booklet. I know that I need one set of points, and I know that I need the slope. Okay, that's all I need. Now, This is for the line in red. So do you have a point for the line in red? Heck yeah, you do. Over here, they gave you the midpoint of CD, which is part of the line that's in red. So I already have a set of points, which I will be using 5.5, 1.5. Now all I need is a slope. So how can I get the slope of what's in red? Well, remember, and this is usually the procedure you have to do actually. See, remember the line in red is a perpendicular bisector. So if it's a perpendicular bisector, it has the perpendicular slope to the line that's in pink. So the next question is, can you get the slope of the line that's in pink? You can. So the procedure now is going to be slope of pink perpendicular stuff, or perpendicular formula, and that will give you slope of red. Okay? I know I'm saying this in a very ooga booga sort of thing, like slope of pink, perpendicular formula, slope of red. But it really is that simple. It's 3 steps. Find the slope of the pink, apply the perpendicular formula, find the slope of the red. All of this makes sense because you understand that you have a perpendicular bisector. You understand that the red line is perpendicular to the pink one. That is extremely important that you never forget. The Voronoi diagram is filled with perpendicular bisectors, and that helps you understand that you can get the slopes of all of these guys. See? Now you might be thinking, okay, so slope, how do you find slope? Go to the formula booklet, find slope. Here it is. You might be saying that's gradient, and I will tell you gradient equals slope. The first thing I'm going to mention is that I know it's taught in a lot of different schools and areas and whatever, okay, that slope is really what they call rise over run, okay? How much you rise divided by how much you run. And I mentioned this because this equation suddenly makes a lot more sense. You have an XY coordinate plane, ¿cierto? So your X is clearly your horizontal, while your Y is clearly your vertical. And so if X is your horizontal, it's going to be how much you move side to side, it's how much you run. While your Y, which is your vertical, going up or down, is how much you rise. So that is why it's rise over run, because your Y values are up top, while your X values are on the bottom. So that's just a small hint. That is why we call it rise over run, okay? Now, more importantly, how does this formula actually work? You have the little y, y1, y2, x1, x2. This is not y squared or x squared or anything like that. All this is really telling you is your first x with your first y and your second x with your second y, okay? So in terms of points, you have like x1, y1, x2, y2. All right, so which one is your first point? Which one is your second point? That's all that's really happening. Clearly, the first point of my line that's in pink is point D. And point C is going to be my second point, right? So what are the coordinates of C and D? This is so much easier than what you think. It's staring at you right now. Point D has x coordinate of 4 and of 1 over here. Point C has an x coordinate of 7 and a y coordinate of 2. So suddenly, now for the slope, right? Well, following this procedure that went up here, the 1, 2, 3 over there, the slope of the pink, right, is going to be following the formula, which is y2 minus y1 divided by x2 minus y1. Well, you can define your first point and second point however you wish. In this scenario, I'm going to call this my point 1 and this is my point 2. So if that's my point 1 and this is my point 2, that means this is x1, this is y1, this is x2, this is y2. So if I go ahead and plug in like that, the slope of the pink following step 1, ¿cierto? I have 2 minus 1 divided by 7 minus 4. So that gives me 1 divided by 3. So that is the slope of the pink one. I double check quickly. On the one hand, it's a positive value, so it makes sense because this is a line that's going up and it's not increasing too fast. 1 over 3 makes sense. And even more so 1 over 3. So this is my rise up top with 1. This is my run on the bottom. I'm rising 1 square and I'm running 3. Checks out to me, doesn't it? So there's my rise over run. This is the slope of the line that's in pink. See? I apply the perpendicular formula, which I have down here, which actually, is it over here? Perpendicular gradient. I don't think it's up here. This might be the kind of thing that you have to memorize, see, or learn thoroughly. So now you apply the perpendicular formula that's right there, see? So for the perpendicular formula, let's remember that we said that the slope of the first, if they're perpendicular, right? If they're perpendicular, the slope of the first times the slope of the second gives you -1. So the slope of the first, which we are calling 1 over 3, times m2, which is the line that's in red, has to equal -1. So to get m2 alone, clearly all I have to do is just times 3, right? Times 3 to both sides, so this goes away with this. I end up with m2, which is my line in red, right? And now it's step 3, giving me the slope of red. I end up with m2 equals -3. And m1 over here, so this is m1, right? So m1 is 1 over 3. Okay, I should have specified that earlier. m1, which is the line in pink, is 1 over 3. m2, which is the line in red, the perpendicular bisector, is -3. It makes sense. If this is rise over run, that means I have a rise of -3 and a run of 1. So rise of -3 go down 3, and I run over 1. Checks out. Makes sense. All right. That was a very long but complete explanation of how the slopes work. Now you establish the slope of your perpendicular bisector, which we said was -3. So from here, you can plug everything in. And the main objective, let's not forget, is reaching this right here. See? So on the one hand, first I plug in. So I'm going to plug in y minus y1, which we said was 1.5, equals m, which is -3, times x minus x1, which we said was 5.5. So just so that no one gets lost, this is x1, this is y1. Now, you need to reach what's this that's here. See? Now this that's here, take a close look. All that really matters is that y is alone. So as long as you search or make sure that you reach for y being alone down here, you should reach something similar to that, right? And this is no different than what I said earlier, that from here, you're going to pass to that, okay? Just make sure that y is alone in order to get the different sort of ways in which you can express a straight line, yeah? So, from here, the first step that I like to do, okay, is that I distribute, see? So I end up with a y minus 1.5 equals -3x plus -3 times that. Now -3 times that, I could do it by hand, but why would I? So here I pull up my fancy calculator and I can do -3 times -5.5. 16.5. So plus 16.5. I can do plus 1.5 to both sides. I end up with y equals -3x plus 18. I double check up here. It's exactly what I have. See? So for part A, it's fairly simple, but there is a lot of procedures and explanations that you need to understand why you're doing what you're doing. The lines of math are not that hard, but understanding, to my knowledge, or to my perception, understanding perpendicular bisector is the #1 thing for Voronoi diagrams. See? So once you understand that the line is red, is your perpendicular bisector of the line that's in pink, everything becomes much more friendly. Also remember, oftentimes this is easier than what you think. If you have a Voronoi diagram that is giving you the different square distances and is giving you the 1, 2, 3, 4 down here, ¿cierto? You can probably find a lot of these points just by looking at it. See? I literally found the coordinates of D just by saying, okay, this is 4, this is 1, bada bing, bada boom, 4,1. Oftentimes it's easier than what you think. That's what I'm trying to tell you. See? Yeah, that is for part A. Pretty simple. For part B, we need to complete the Voronoi diagram shown above. So, notice, site B is split up from C with this perpendicular bisector. C is split up from D with this perpendicular bisector that we just found. B is split up from A with this perpendicular bisector, and B is split up from D with that perpendicular bisector. So which one do we still need to split up? We still need to split up A and D, okay? So let's talk a little bit about how we would do that. It's much simpler than what you think. It's much more straightforward than what you think. On the one hand, they're on the same sort of like Y level, okay? So because they're on the same sort of Y level, the approach is actually fairly simple. But let's still make it as rigorous as possible, see? So this is like the OG line between A and D, and I need to draw a red line somewhere here, okay? I'm not sure where, I'm not sure where the perpendicular bisector is, but you do know that the perpendicular bisector bisects it. It divides it by 2. So what is the distance that I have in pink? Well, clearly you're going from from 1 to 4. So from 1 to 4, you count how many times? 1, 2, 3, you count 3 times. So the distance from A to D is 3. So the perpendicular bisector has to be cutting where we have 1.5 on both. Okay. So where you have 1.5 on both, well, let's count it. Here you have 1, ¿cierto? So 1 plus 1.5, 1 plus 1.5, just so that you all trust me, is 2.5. So boom, your perpendicular bisector has to go on 2.5, like this. And there is my answer, okay? That is my perpendicular bisector, and it's perfectly vertical. Why is it perfectly vertical? Because A and D, the line that's connected in pink, is perfectly horizontal. So, complete the Voronoi diagram shown above. You can just draw like this. It's good enough. If you want to be more rigorous on your approach, you would say something like, I don't know, that A is 1,1, ¿cierto? And D is 4,1. So A is 1,1, D is 4,1. Maybe you would say midpoint, right? Midpoint has to be between the both. You can use the midpoint formula that's over here, if you like. But you can use this one here. But really, visually, you can just sort of tell the midpoint has to be at 5 divided by 2. So at 2.5, right? The same thing we concluded visually. So you can say that the midpoint is at 2.5, 1, right? And perfectly vertical, right? You can do the rigorous approach, which is doing all this stuff over here. You're going to reach the same conclusion, you guys. Okay, the equation of your perpendicular bisector ends up being x equals 2.5. This is the equation of your perpendicular bisector. And I really need you guys to understand that a little more thoroughly, okay? Whenever you graph, for example, x equals 2.5, all you're doing is that you're putting a line that goes straight up, and notice the x values. The x value doesn't change. The y value does, but the x value doesn't. So for putting a vertical line, you leave sort of like locked in an x value. And for putting a horizontal line, you leave locked in a y value, okay? So for this line that goes straight up, you just express it as x equals 2.5. That is how we completed the Voronoi diagram shown above. And last but not least, we know that Annie opens an office equidistant from 3 of the cafes, B, C, and D. So that's the other thing I need to mention. All these perpendicular lines that are in red, the perpendicular bisectors, they help you make everything equidistant. It is a fact of the Voronoi diagrams, okay? The equation of the perpendicular bisector of BC, all right, perfect. So of BC, so it's this guy here. So just the line in red that I'm leaving now, the equation of that red line is this, okay? And through there, we need to find the coordinates of the office. Now, because Annie opens an office that is equidistant from the 3 of the cafes, that means it has to be where the perpendicular bisectors are meeting, because the perpendicular bisectors is exactly what helps you split up distances evenly. So if it's between B, C, and D, well, what are the perpendicular bisectors between B, C, and D? It's that one, it's this one, it's this one. So the cafe that Annie is opening has to be this point right there. Got it? Now, what information do you have? They just gave you the equation of this line up here, which I'm going to put in orange. They just gave you that this is that. 3y equals 2x minus 1.5. And you have from part A that this equation here, right, is this guy right there, is y equals negative 3x plus 18. And guys, this is much simpler than what you imagine, right? So because you need to find this point right there, and you know the formula of these two equations, well, these two equations, what do? They intersect right there. And so if they intersect right there, that means they are touching. If they are touching and intersecting, they are equal to each other. So the big idea I need to share for part C is that if they intersect, then they are equal to each other right at that point. So if two lines intersect, then they are equal to each other right at that point. So my first equation, as I mentioned, was y equals 3y, was 3y equals 2x minus 1.5. So 3y equals 2x minus 1.5. This was your first equation. And your second equation from part A is y equals negative 3x plus 18. So if you find the intersect between these two lines, then that's going to be where the two lines meet. That will be exactly the equidistant location that Annie wants to open this office at. Okay? So how do you find the intersect between these both? Well, here you actually have a system of equations. Okay? Notice, the annoying part of looking at both of these individually is that they both have two variables. So as much as the first one as the second one, currently they both have x and y within them, within both of them, right? So it's hard to solve them individually, but solving them together will help. It's going to make more sense in a second, yeah? Here you have two main tools. You have substitution and you have elimination, okay? I suggest you learn one of them like thoroughly, deeply, and then forget about the other one. In this case, I will use substitution, okay? So substitution is, for example, reaching y equals blah, blah, blah in terms of x, plugging that into the other one, so you end up with only one variable. Now, I know that's a lot of blah, blah, so let's see it in action, see? For example, equation 2 is already written as y equals something with an x inside of it, right? So if you take equation 2 and you plug it into equation 1, see what happens. So now you're telling me that y equals this. And you're going to be applying that for the first equation. So if you plug in the value of y into the first equation, you end up with 3 times my new value for y, which is negative 3x plus 18 equals 2x minus 1.5. Just so that no one gets confused, all that's happening here is that this got plugged in here. That's what happened. That's all that happened, okay? And notice, yes, this looks absolutely horrifying and nasty and everything, but you passed from having two variables to having only one. Yes, you have an x there and an x there, but you only have x's. Before you had x and y, now you have only x. So that means you can reach x equals an actual number, which is what we want to do. Ah, look at that. So from here, I only have one variable and I only have x. And that's the magic of system of equations. Through substitution and through elimination, you go eliminating variables. In this case, I eliminated y. And I used substitution. See? So, enough blah blah, let's get into it. From here, you can go ahead and distribute, ¿cierto? So you can do with 3 times negative 3 gives you negative 9x, plus 18 times 3 should be 30, 54, equals 2x minus 1.5. Okay? Seems good to me. Yeah. From here, I like to keep my x values positive, so I'm going to do plus 9x. Plus 9x, 54 equals 11x minus 1.5, plus 1.5 to both sides. 11x will have to equal 55.5. So here I just flipped it at the very end. I like having x on the left side. Here you can divide by 11 to both sides, and x has to equal, I'm pretty sure that's just 5.5, but let's double check. There's no reason not to. Yeah, 5.045. And checking the Voronoi diagram, it actually kind of makes sense, because if you look, 5 is right here, and where they intersect is a little bit to the right of that. So it makes sense that it's going to be 5.0 something. See? So your x value ends up being 5.045, right? If you want to do significant figures or values or whatever, you count 1, 2, 3, round it up or keep it the same, you round it up. So I'm going to leave my x value as 5.05. That it? And with 5.05 for your value of x, now you can just plug it in anywhere up there, either to the first or second. I'm going to choose to plug it into whatever the second one, see? So I'm going to plug into the second one, the value of x. I end up with y equals -3 times my value of x, which is 5.05, ¿cierto? Yes. Plus 18. So y has to equal whatever that is. So let's find out. -3 times 5.05. Yeah, -15.15 plus 18. So your value for y ends up being 2.85, probably. Quick maths, there is 2.85, just double checking. So boom, this is the x value, this is the y value of this coordinate right there. See, so if I get really, really fancy, I would be saying that this is 5.05 and that is 2.85. Okay, so the coordinates of this office combining the x and the y is going to end up as 5.05 comma 2.85. I check visually with the graph, it makes sense. That would be for number 7, you guys. All right, just to show you the answer key, well, I always put it down in the videos, but anyways, here is the show that for part A. Here is completing the perpendicular bisector of AD, a vertical line with x-intercept 2.5, ¿cierto? And for C, there are my 2 solutions, okay? Technically, I guess I could have, rounded it up a little bit, this or that. I ended up with 2.85, ¿cierto? For using significant figures. Okay, so don't freak out. I know it's different than the 2.86, but that's because I'm using significant figures for this calculation, okay? It says to accept it, so don't worry. All is good over here. Ladies and gentlemen, that is for number 7. That is for Voronoi diagrams. I hope it helped, and I'll see you around.